Yes, ma'am.
Start, Malla.
Ma'am. But
Good afternoon, everybody. Today we are here to attend this seminar on abstract algebra and its application. Algebra is one of the main branches of mathematics, which has its wide applications in many fields. With a strong knowledge of basics and knowing about its real life applications, students can ward off their worry that algebra is the toughest part of mathematics. This is what I believe. Now, on behalf of our Honorable President, Dr. H. Ramrao, Honorable Secretary, Professor S.N. Nagaraj Reddy of National Education Society of Karnataka, and our Principal, Dr. G.B. Panduranga Nayak, I welcome all the participants, both students and faculty members from our college and also from different colleges. I'm happy to give a brief introduction about today's speaker. Dr. Rajni Kanwar has done her MSc. Dr. Rajni Kanwar has done her MSc, MPhil, and PhD from Himachal University, Himachal Pradesh, with algebra as her specialization subject. She is also a gold medalist in MSc and has received both junior and senior fellowship award from UGC BSR. She has also worked as a principal in RS College of Management and Sciences, Bangalore, and is a subject expert in school page and Elevate score. As her utmost interest is in research and academics, she is currently working as an assistant professor of mathematics in Presidency University, Bangalore. I warmly welcome you, ma'am.
Thank you, ma'am.
Over to Rajni, Dr. Rajni Kanwar now.
Good afternoon to one and all. I welcome all the faculties and the students who are participating. And I thank to Mrs. Gayatri to provide me this opportunity to have this webinar. And the main topic of this webinar is, as the name suggests, abstract algebra and its application. But before I move to its application, I just wanted to have a small brief introductions of the mathematics, because most of the people who are here, who must be participating right now, must be from mathematics field, either the faculty or the students. Even if they are from other faculty departments, they will feel interested in this topic. So mathematics is divided into two branches. Generally, we divide it into two branches. One is pure mathematics and another branch is applied mathematics. Once we heard applied mathematics, we have seen most of the people, they are inclined towards applied mathematics, as the name says, applied. Because what they feel is that as it is applied, so it will give us, its application is broader, so it may give us more opportunities. Okay, like all your dynamics, all your mechanics, aerodynamics, everything, your aerospace, everything is all dealing with that of the applied mathematics. But my main concern over here is that I want to people to look towards the pure mathematics, which is your algebra. Algebra is considered to be the heart of the pure mathematics. And most of the people, they are not aware about the applications of algebra, how it is applicable to our day-to-day life. So the main aim of this webinar is to make the people aware, especially the students, to aware what is algebra and how it is applicable, why it is important in our daily life, how it is important, and what was the history behind it, what was the requirement, and how it is applicable. So the question arises is, what is algebra? Okay, so if you take it in a broader part of mathematics, if you talk about the number theory, if you talk about the geometry, you talk about the analysis, everything of geometry, number theory, analysis is a broader part of algebra. So they are the part of the algebra. Okay, and it includes everything. Even if you try to solve the elementary equations, for this to study the abstractions such as group rings and fields, I will not discuss right now group rings fields. We will come in the upcoming slides, we will come to these topics related to group rings and fields. But in the initial slides, my main aim is to develop the interest in algebra, so that people can understand, so that who all have taken out their crucial time to attend this webinar, they can get the brief idea about this. So I will start with this elementary algebra. I'm using this word. I will come to it. What is the meaning of this? I will say right now that it is essential for any study of mathematics, science, engineering, as well as application as medicine and economics. One by one, I will come to this. All right. So I will start. Even algebra is further divided into elementary algebra and modern algebra. So if you go and more, if you go to the elementary algebra, from the very beginning of our daily life, even of a baby, it starts with that of the elementary algebra. How? In the upcoming slides you will come to know. So right now I will just want to tell you elementary algebra. Just keep in mind plus minus as it is shown in the diagram. Plus minus multiplication division equal to. So these are the basics elementary algebra. So you can be well versed now with these, with the help of these symbols. How without these symbols we cannot survive. We cannot survive. Take any branch of astrology, take any branch of astrophysics, take any branch of science, take any branch of arithmetic, or let's go to the layman language, take any daily routine. We cannot survive at least plus minus division multiplication. So that's from where the importance of the algebra in our life starts. Okay, moving to the next. If you work your research area, if you're a specialist in algebra, they generally give you the term algebraist. Okay, so this is one of the main this thing that I want to tell you, and it has a algebra is also used in certain specialized way also. Like most of the faculty who are here, they must have talked about linear algebra, algebraic topology. So what are those? That we will come to further. How we gave them those particular names and what is the difference? How they becomes the branch of algebra, like linear algebra, algebraic topology. How it becomes. Okay, moving to the next slides now. These upcoming slides will explain why algebra is important in your life. Okay, so as I said, mathematics is one of the first thing you learn in life. When you are a baby, you can see that when we have a baby in our kids, we all our family have a family where you must have seen your kids growing from the age from 0 and to this age. Maybe some few of them are teenagers right now, but when they are baby, when they learn started counting also, so those counting is one of the basics of your algebra. When they build blocks, nowadays blocking game is there, building blocks, how to count them, how to move them, how to make a different shapes from them, how to make different objects and figures from them. All these are the basics. These are the preparations, important preparations of algebra. So we can see, so from this slide it is clear to us that for even a baby starts with the algebra. So this is the first, the foremost application of the algebra in our daily life. The next is now key to opportunity. So there are the years of small beginnings until the day comes that you have to be able to do something as intricate as algebra. So what happens is once we grow up, so what kind of a key to opportunity you're going to handle over there. So all these things, if you are specialized in the field, if you have the ability to do the basic algebra, you can succeed in any field. Because I'm just talking about till now, I'm just talking about elementary algebra, just keeping those 5 symbols in your mind: plus, minus, multiplication, division, and equal to. So if you know to do the plus, minus, multiplication, division, and equality, if you know all these 5, if you know how to play with these 5 symbols, your basic algebra is very strong. So that basic algebra will give you the key to opportunity, whether you're going to be a part of, I'm talking about the students, whether you're going to part of an IITs, whether you're going to part of NASA. If you're well versed in them, you can easily go and you can easily be the specialist in those. Moving to the next now. Prerequisite for advanced training. So this everyone knows that if we are employing, even if our HOD, like Gayatri ma'am is the HOD, so even if she is employing whenever she employs a new faculty in mathematics department, what she will do is, first thing that generally the people will ask is, give us the demo. So once they give us the demo on one particular topic, what they try to do in that demo, they try to ask you whether you're well versed with those symbols which we're using in that. For example, we are talking about algebra. So let's talk about group. So suppose someone came and is standing in front of Gayatri ma'am, and two, three faculties are sitting and in a panel, and they ask you to present on a group. So what you will start? What will go to your mind? You will not start with the definition of a group. You will start what is the basic of that. You will start with the sets. You will start how the binary operations are applicable on those sets. You will start what all the four properties are required for those framing up of the group for that particular set, how the binary operation is applicable. So this is how your HOD will be able to judge you that how much knowledge you have. And once you go to set what you're doing, you're just talking about the basics. When you're planning to apply the binary operation on those set, what you're doing, you're just applying binary operations. When you're applying the binary operations on the elements of the set, what you're doing either plus, either plus, minus. You're just playing with those four beautiful symbols: plus, minus, multiplication, and division. So this is the prerequisite for advanced trainings. So that is the prerequisite requirements. If you're well versed, then you can easily go and easily excel. If you're well versed with those five symbols: plus, minus, multiplication, division, and equality, you can easily go and survive anywhere in the world. How now? Next slide. It deals with the science. So when we are doing any form of sign, whether we are dealing with a project or a lifetime career choice, you will have to be able to do and understand how to use and apply the algebra. So in this picture also, you can see I have put some symbol: plus, minus, division, etc. So if you are able to do this with any form of science, so let's talk some example. I will not go ahead without with giving you an example. And I right now my main aim is to develop the interest of you people in algebra. So go to the any form of the science. Let us talk about once the lady, a housewife, will discuss about her. Okay, so she's getting up and she wants to measure the volume of the container of the milk which is coming to her house. So what formula she will apply? She will see the shape of that container, cylindrical shape. She will apply the formula of the volume. But once she applies the formula of the volume, she cannot apply she knows the formula of the volume, but she cannot apply until or unless she knows to multiply. And what is a multiplication? It's the elementary basic algebra. So this is how your daily routine. Now let us take another example of the science. You will see various examples I have quoted also. A person is driving his car going to office. He wants to calculate the speed of his car. He wants to calculate the distance. He wants to calculate the average of the petrol being used. You cannot survive with you know all the formulas, but if you don't know to multiply and to divide, you cannot. If you don't know multiplications and divisions, you cannot survive over there. That is a fact. Okay, so how our basic lives, I think I have given the enough examples in which our basics life, our basic routines of our life, like starting from the life of a lady with a milkman, and to a person who is going to an office. Nowadays everyone goes, they're calculating the speed of the car, calculating the distance traveled, calculating the average of his car. Everything we require formulas, and those algebraic formulas are there. But if you do not know elementary algebra, that is those five symbols: plus, minus, equal, multiplication, and division, and how to create an equality, if you do not know those basic calculations, we cannot survive. So that is the importance of basic algebra, that is elementary algebra, in our daily life. Now let us say for the data entry also. When you are entering, what about the entering of any data? You use the algebraic expressions and use the equations will be like a cornerstone when working with data entry. I'll give you one example. Like nowadays, most of the people, we are using the MS Excel sheets. Like suppose in engineering branch, or as your college is dealing with the basic sciences. So if you have 1,000 students who are coming to the college in 1 year, okay, entering to your college. So you want to calculate the average score. If you're going to do it with a calculator, it is going to take a long time. So MS Excel nowadays we are using. So what we do over there, we apply the formula. If you do not know how to select, how to add, how to divide, we cannot do that. So even for entering the data, your algebraic skills are checked, whether you are well versed with those algebraic skills or not. So those are checked. Moving to the next slides now. Interest rate. Everybody wants once we get the job, the first thing we start thinking about is our savings. So for savings, the first formula that comes to our mind is interest rate, that which bank is giving us how much interest rate, and how much money we are going with. If I'm going to save, let us say 10% of my salary every month, then after 10 years what will be my total savings? So all those interest rate, all those, with the help of the calculations of the interest rate, how to divide that, how to multiply that, how to calculate your amount which you will be having after 10 years or 20 years, maybe at the retirement age, because we generally says that planning is required. So if all those things involves the basic algebra. So basic elementary algebra is nothing but it has become so much a part of our life, but we do not know. We generally, even then we incline towards the applied mathematics. Yeah, applied mathematics plays a very important role. It's a great role, but these examples are set up by me so that we can know that how from morning till the moment we wake up till the night we sleep, our routine from the morning, let us say if you're getting up at 7 o'clock till the night and 12 o'clock, your those hours, how it is being dominated by algebra in our life. Okay, and one very interesting examples which algebraists can work on it is, there is a person over here. Okay, so a small school kid, so he want to get home from the school one day, and he's not able to find the key. So how would you get into your house? Okay, so you may say is that, ma'am, how algebra is being used. Some equation has also been framed over here. So a mathematician or algebraist will always assume, okay, let us say x. He may assume x as a distance, and then how much. Suppose he went from the school, he went first to his friend house, and then he came to his own house. So he has to calculate. One is that he will plan that maybe the window of my house is open, so he may use this y minus 2 equation, something like that. Y will be the distance, x is the distance of the school, y is the distance. You may consider, okay, I'm just saying you can frame up these things in your mind. So one way of getting into the house is through window. Okay, if it is not, then maybe that you will retrace your steps where you have dropped the key somewhere, and something would work out and you will figure out a way to get into your house. So that is how the algebra is the part of our daily routine, daily requirements. Okay, and this is a very beautiful example. Most of us, when we get a time, we will play chess with our kids. So moving how much steps we have to move with our in the chess, that is also how much step you have to start and where to end. All these are your algebra. And one example, if you see one figure is given here, you can see velocities calculation, acceleration calculation. Acceleration is there, then what will be the downward acceleration, upward acceleration. Most of the this is the example from the physics. Yeah, and we call it as a projectile. So when you throw something from here, what will be the maximum velocity it reach, and then once it's fall down, what was its minimum velocity. So, and at that particular point, first of all, you have to find out the component in the horizontal axis and vertical axis. So how this algebra is involved in this? The question is, if you do not know, you can see here on the left hand side tan theta vy over vx. If you do not know division, you can't calculate tan theta. So first point where algebra is involved. Then when if you know the formula of V2, okay, let us take V modulus. The formula is this. If you do not know how to square, if you do not know how to add, if you do not know how to take the square root, you cannot calculate the modulus of velocity. So this is algebra only. To square, to add, to take the square root. This is the algebra only. So every formula of the physics, okay, it involves, here you can see they have put square root of 2g delta y. What you're doing, 2g delta y, you're multiplying 2 with gravity, then delta y, and then taking the square root. So multiplication is the first algebra, elementary algebra. Then you're taking the square root, which is a part of algebra, how to take. So all these things are involved. All the things from here, whether it's a physics, playing game with the kid, walking outside, going to the park, everything. How many steps nowadays we wear smartwatch, in which our smartwatches, they are calculating our heart rate, heartbeats, how they are calculating, everything is involved is algebra, because they are giving you the formula over there. Application of those formulas involve what? Multiplication, division, addition, subtraction. So this is how our every routine of our life is being dominated by algebra. Now I comes to the next component, which is the history of algebra, that why, how it comes, a brief introductions only to develop the interest. So initially it was the Egyptian algebras was being used. They used it was their algebra. They used to solve the algebraic problems which were equivalent to linear equation and one unknown. When they started way beyond, very early in 1650, so what they used to do is they used to solve, initially they just know about the linear equation and one unknown. Nowadays we know that when you're solving the homogeneous linear equations also, we are working with more than three unknowns. And what is a degree? As it is a linear equation, so degree is going to be one. And they do not use any symbol for that. Their algebra was rhetorical. They were not using any symbols. Okay, the problems were stated and solved verbally only. There was no written records. Okay, so and then one scientist, his record has been seen in Egyptian, who solved the system of two-degree equations. All right, then comes the Babylonian algebra. Okay, it was advanced as compared to that of the Egyptian. It was again, it was also rhetorical, and they could solve the quadratic equations. Method was solving was rhetorical, taught through examples. No explanation of findings were given, and they started knowing about this rational numbers. Then comes the Greek algebra. So these are the brief histories about them. How the Greeks, they originally learned algebra from Egypt, as indicated, because it is in their writings. If you go back to the history, this is the history. But we should know. Everyone know Pythagoras. It's a very famous theorem. Then we know about Euclid also. So, and we know a very famous scientist, Diophantus, because in number theory, once you open the first chapter, you will study about the Diophantine equation. So all these things has come from the Greek algebra. Then you have syncopated algebra also, and they started with a Diophantus who used the syncopated algebra in his Arithmetica, and then in most part of the world, Greek and India, rhetorical algebra persisted for a longer time. Okay, so they were using for more time. They were using rhetorical algebra where the symbols were not a part. Because you can see that Aryabhatta in India, okay, first century CE, from India, first century, because you can see, you know that Aryabhatta, he discovered the zero, and without zero we cannot survive. If we don't know zero, we don't know 10, we cannot, we will be just knowing only 1 to 9. Even if you want to know, okay, we become so advanced that we know the negative numbers also, then from -1 to -9, we can't think of going for 10, and we can't think of going further. So this is how the algebra, Aryabhatta, who discovered this thing zero, and Brahmagupta, who also contributed a lot. So they were also studying about their components were also this algebra only. Now comes the abstract algebra. So now we have moved a lot ahead in algebra. We are not limited. We have not limited our discoveries, our reading of the mathematics till our daily basics life. I've given enough applications. So it has been further been expanded to groups, rings, fields, modules, and vector space. And we know that nowadays when we deal with that of the sets, that how natural numbers is a subset of integers, in further subsets of rational number, further subsets of irrational numbers, and further subsets of real number, and further all these numbers are contained in the complex numbers. So all those things now they are becoming, because these things are being used, vector spaces, you're using fields, you're using the complex field, you're using the real fields. So it has been expanded now to a broader sense. Okay, so now, and then we move further. This it's a favorite game of every generally a teenager kids. They will. I have seen most of the people, they're holding a Rubik and trying to convince. But I will give you a very easy this thing of this thing. If you know how to define a group, permutations of Rubik cubes, you can have a group structure, and it will be a fundamental. It's a fundamental concept within the abstract algebra. First basic concept of abstract algebra, group. I will also come to you why there was a requirement of framing up a group. That is in the further theoretical portion of algebra. Right now, I'm just giving you some examples. All right, so this was the 19th century who all explored. Like British mathematicians were the persons who explained about vectors, matrices, and transformations. They are the part vectors, matrices, and transformations. They are the part of the linear algebra which we come. Galois, he has done a wonderful job in mathematics. If you go and check the research papers, still his theorems, many work is being done on his theorems. He has done wonderful in mathematics, though he lived a very short life of hardly 21 years. But if you go and see so many, even today's in algebra, if you open up a modern algebra, if you open up an advanced algebra, you will see Galois theorem. You will see Galois theorem, and in every higher level research paper, always the Galois name is always there. His theorem is there. People are doing different work on them. So though he lived a very short life of 21 years, but his contribution was amazing. So the concept of group sets of operation with a single operation which satisfies three axiom, that it was he who gave the basics of that. Then Calais theorem also we studied in algebra. When we study the group theorem, we studied about the Calais theorem also, which is related with that of the group theory only. So he further developed, he further carried out his work. Then vectors in three-dimensional space. Yes, this was also biggest contribution. This was done by an American. His name was Gibbs. So this was the history of algebra and practical applications. So that was the first part of this presentation. Now I move to the main part, a little bit theoretical. First half of my aim was half of the hour of this webinar. My aim was to develop your interest in algebra because I explained you how from the moment you wake up till the moment you sleep, this everything, even your heartbeat, is being done by the algebra only. So let's move ahead to the higher parts, higher version of algebra, because my main aim for the students who are here and even for the faculties who are interested in algebra is to develop, to do further research in algebra. If you go and check the algebra's papers, higher journals of the algebra, like Journal of Algebra is one of the highest journal of international level. It comes under the top 20 algebra, top 20 journals of the world. Okay, and then one is algebra and its application, Journal of Algebra and its application. If you go over there, you will always see a very complicated things over there. If you pick up one theorem, you try to solve it, it may take you 30 days also, 1 month also. Because for understanding that problem only, we have to understand at least 20 words. For understanding those 20 words, sometimes we have to read 10 pages for each word. So that is now that it is to that level the algebra has reached now. So that is what I wanted to tell here. So first, abstract algebra is the study of algebraic structures. What are the algebraic structures? We'll come to it. So how the linear algebra comes into existence. When we try to solve the system of linear equations, you must have seen when we try to solve the system of linear equation in junior classes, we deal with the two equations or maximum three equations with three variables. But what will happen if you have a more than three equations and more than three variables? That becomes the basis of this linear algebra. Okay, a whole algebra, one complete part of algebra is on that linear algebra, which contains the moment if this question strikes in your mind, what happens to the equations if you have more than three equations and more than three variables in that, what will happen to that equations, how to solve that. You have to study about the vector spaces. You have to move ahead and you have to start studying about the vector spaces, and it's very interesting portion of the mathematics. Okay, so that is where the vector spaces and linear mapping between such spaces are being done. Okay, so that is when you start thinking of solving the system of linear equation, it deals with the linearity, and you will come to know that matrices is also, then they further try to solve it with the help of a matrices. So matrices of a higher orders are also a part of a linear algebra, where you study about the rank and nullity. Most of the faculties are aware of that. So solving the system of linear equations leads to the linear algebra. Now the next comes why we require group. As I told you, then what happens is the people, they try to find the formula for the solution of general polynomial equation, because linear equation we came to know. When we were trying to solve the linear equation, we came to know, okay, we have to go and move a few steps ahead. We have to start studying about the vector spaces. But when it comes to the polynomial equation, what are the polynomial equations in which the degrees are higher, x to the power n, a naught x to the power n plus a1 x to the power n minus 1, up to so on. Okay, what we can do, how we can solve those system of linear equations. Here in the linear algebra, we are just giving the solution where the degree of the each variable is 1. So this attempt has been solved. This has resulted in the discovery of the group, which is now a biggest branch of the mathematics of the pure algebra. And if you have the knowledge of a groups, you can produce as many as papers as possible. Further investigations of quadratic and higher degree forms results in rings and ideals. So after groups, the rings and ideals will come. I will come to it because the groups has 4 property. What are those property? I'll come to it. Okay, so if I want to grow for the algebraic structures, they includes now group, higher algebraic structures. Group, ring, field, modules, vector space, lattices, and algebra over a field. Okay, they are from higher mathematics. Yes, any doubt to anyone? Okay, so I'll move to the next slides. Before we move to these bigger words, before we go to the bigger words like groups, rings, fields, modules, vector spaces, etc., the very basic requirement, well, like once we start with the junior classes, if we require addition. Okay, but when we teach the students how to add, okay, same is the
Excuse me, madam.
concept. Yeah, ma'am.
The screen is not shareable, madam. We can't see the screen. Somebody has shared their screen.
Okay, ma'am. So I will share it again.
Okay, madam. Thank you.
I will share it again. Can you see it now, ma'am?
No, madam, not it.
Oh, okay, wait. Yeah, ma'am. Can you see it now? Yeah, okay. Yes,
Yes,
ma'am.
madam. Now it's okay. You
Okay,
make
ma'am.
it full screen, madam.
Okay, ma'am.
Okay, thank you.
Can you see it now?
But not full screen. We are seeing the slides only. Better you make it full screen.
No, it's not working actually.
Then it's okay, madam. Now it's coming anyhow. Thank you.
Okay, so you're seeing the binary operations. We were discussing about the binary operation. So this is one of the basic, like when we go to the school, we start learning about the addition. Once we start with the addition, we start with one very beautiful sign plus. So it is like that same is for the binary operation. If you're studying about, if you want to start studying about the group theory, because once you open the algebra book, first thing in the first chapter, you will be studying about the binary operation. What is it? If you will be dealing with one set, okay, in which you will be mapping the Cartesian product to that set. How you're mapping that operation may be plus, that may be multiplication, that may be division, that may be subtraction, or may some other rule also, like it may be a star b divided by 2, any rule which they have frame up. But the condition over here is the element from the one element is from S, another element is when you are applying it on the same set, it should come to that element of that particular set only. So that is how you apply the binary operation. Yes, yes. Can I carry on with the next slide? Yeah. So further we have like a very beautiful example I'll give you to understand the binary operation is if you go for this set of if you go for this matrices of 2 by 2 with real entries and you divide another one formula on that f of a comma b is a plus b where a and b, that function on a comma b is such that when you're applying the Cartesian product, here the Cartesian product is that when you're applying is a set of the matrices, it is going to the addition of those two matrices. Then you know that sum of the two matrices of any matrices of order 2 by 2 is another 2 by 2 matrices, so it will be a example of, it will be a binary operation. Now moving to the new term, magma or groupoid. Okay, so if in abstract algebra, a magma or groupoid is a basic kind of a algebraic structure. Okay, what does it consist? It consists of a set. That set should be equipped with a single binary operation, and another property it should satisfy is it should be closed. The very first property of the group algebra, it should be closed. Close means when you take the two elements from the set M, you apply the operation on them. That element, after applying the operation on those elements, you should be getting the element from the M only. If it is the situation, then that is known as a and we call it as a groupoid. Yes. All right. So now we will move towards early group theory. In earlier, what all were known, we were knowing the algebraic operations on numbers, because you can see algebraic operations if you apply additions on the natural numbers. If you take
ಸೌಂಡ್ ಆಫ್ ಆಯ್ತು. ನೋಡಿ ಇಲ್ಲಿ ಸೌಂಡ್ ಏನೋ ಬರ್ತಾ ಇದೆ, ಇದು ಎಕ್ಸ್ಪ್ಲೇನ್.
Yes. Yes, somebody has muted me. Please kindly do not do that. I will be, because I'm getting disturbed in between the lecture. Somebody has muted my mic. Please, I request you, do not do that. Okay, so we were studying about the earlier group theory. So what we were having is now, this was the earlier group theory. The Euler, everyone knows him. He was one of the person who started with the algebraic operations on numbers, and then he generalized the Fermat's little theorem. This is also one of the very famous theorem. And then then the person Gauss, he developed the concept of the cyclic and generalized the abelian group. So how they differ, if you go in depth, you know what is a group. Group will be having the four property: closure, associativity, identity, and invertible. If it becomes commutative, that is abelian group, and cyclic is when each element of a group can be produced by a single element, then that becomes a cyclic group. So all these properties are given by these followings famous mathematicians. Kronecker, he gave his own permutation group, which nowadays is appearing as a very big field because it has a lots of applications involved with this. Then Lagrange's, everyone knows him. All these Cauchys, Calais, they all have contributed a lot towards the pure mathematics, that is the algebra. Then if you move ahead, modern algebra. So what happened is that by the end of the 19th century and beginning of 20th century, it saw a tremendous shift in the methodology of mathematics. Here, this is in the 20th century where, excuse me, abstract algebra emerged by the name of the modern algebra. Okay, its study was the part of the drive for more intellectual rigor in mathematics. Assumptions in classical algebra, on which the whole of mathematics, that is natural science, depends, took the form of axiomatic systems. So from the 20th century, this inclinations of mathematicians, towards the algebra, it increases a lot. After that, so many new results came. So these were Kronecker and this Richard, who had considered ideals also. This is the history. If you further people who wanted to do research over them further, they must be knowing that how ideals in commutative rings and the representation theory of the groups came to define. And this is by these famous people. Frobenius, he's a very famous mathematician. His contribution is towards the physics is also there. So then you have the monograph this published from the theory of the equation. So from where it started, the main mathematics, this started from there. So if you go in depth now, examples of algebraic structure with a single binary operations. So these are the few basics. Now I will, because that was the history regarding your higher mathematics related to the research point of view. So if you want to, if we want to study how the binary structure, how the algebraic structure with a single binary operations. They just have a one binary operations. First is a magma. As I have already explained you what is magmas. Magma is one of the basic algebra structure which only has one property, that is it is closed. If you add a property associativity to magma, it becomes quasi group. If you add the property of after quasi group, it is semi group. Okay, quasi group. If you add a property of identity, it becomes a monads. If you add a property of invertible to monads, it becomes a group. So this is how all these magmas, quasi group, monads, semi groups, and groups, they are interrelated. And it's very interesting that how by eliminating one property from the group, it will become a monads. Once we eliminate one more property, it becomes semi-group. Once we eliminate one more property, it becomes quasi-group. And if we eliminate all the properties, just keep the binary structures, basic binary structures with one algebraic structure with one binary operation, it is magma. All right, so nowadays, these are the complicated, that's why I have written here complicated examples, rings, fields, modules, because for studying of the rings, you need to have a two binary operations. These all are with the multiple binary operations. For field also, for rings you require two binary operations, fields also you require two binary operations. Same is with all of these. Vector spaces, if you want to define algebra over field, then also you require the more than one binary operations. Now the comes for higher, what are the contributions? Till now we discussed about the basic contributions, how the algebra is applicable from our daily routine in our daily life. But these are the applications here in many field of mathematics and science, how it is being used. Algebraic topology, initially only in the beginning I use this word that it has been specified further branched, it has further branches as linear algebra and algebraic topology. So this uses algebraic object to study the topologies. Those who are well versed with this topic, the topology, this is also one of the branch of mathematics where you deal with the open close compact spaces, Hausdorff spaces. So all those, they are the part of the topology. So how to apply algebraic equations, algebraic structure on them. So that is your algebraic topology. So then fundamental group of manifolds. If you go to the physics, you must have used this word manifold. Nowadays, even in graph theory, manifold is being used. Okay, so this you can correlate that with the with one of the application of this, and how you can combine the algebra over there will be giving you a broader area of the research in that field. Then you have number theories, like number rings that generalize the set of integers. How? So all these things, they are the which is the research has already been done, and it's a broader scopes for the research nowadays. Then we have group-like structures. Here, this table I have drawn you, group-like structures. We know that group has the four conditions: associativity, identity, divisibility, and totality. Totality means closure property, and then commutativity. If all the four properties, four properties are satisfied, then it will have group-like structure. And if you have all the five properties, it will become a abelian group. So if you have only one associativity, so you will say that it is a group-like structure, because I told when it is having only associativity, with it, then it is the basic binary structure which has the associativity property only. And when you have this, associativity, identity, and divisibility, we call it as a loop. We call it as a loop. When you have associativity and identity, okay, with it, we call it as a monoid. A closure property should also be there. So this is how with the different combinations we have a group-like structure. But at the end, last two, if you say all the four are satisfied, then it will be a group, and all the five are there, then it is going to be a commutative. So further, this is the representation theory. Again, this is also a branch of mathematics which studies the abstract algebraic structures by representing their elements in terms of a linear transformations of the vector spaces. So representation theory is also very famous nowadays. People are working a lot on it by taking the representation theory of various different types of the groups and further broader sense. And it also being its elements by matrices also nowadays. Matrices, they are also a very hot topic related to that of the algebra, how we are applying various different operations on it. And then these are the basic definitions for vector space, how we define the vector space over a field, how we denote it, matrix multiplication. So representation theories is nowadays. I will end over here. So that is all for today's. And if you have any queries now, you can ask from me related to anything related to today's class, today's session, today's webinar, and anything required for this. Yes, anyone having any queries? Yes, anyone having any queries who are present over here? Yes, Gayatri ma'am.
Hello.
Gayatri ma'am, any queries?
Right now, we don't have any queries, ma'am. Please continue with the topic.
Ma'am, the topic is over. That's why I told that if they want to know anything about this.
Right now.
Anything they want to know.
Yeah, I will ask. You can just, we shall wait for a few minutes. If anybody is having any questions.
Okay.
No. So, participants, please, you can put your questions.
Hello.
Ah,
Hello,
sir.
ma'am.
Hello.
Ma'am,
Hello.
you said there are a few research areas, topics that you can pursue in this particular thing. Can you give us a link to some papers, madam? Current papers
Yeah, sir.
on the
Sure.
topics?
Yeah, sir. Actually, you're working on a which field? First thing is that that is what I want to know.
Uh,
Which?
my uh,
Yeah.
my field is a different one, madam, but I'm interested in rings and fields and vector spaces, and
Okay.
also the moners and groups topics.
Okay. Yeah, sir, very good because I'm really keen if anyone has this kind of queries. You have for the finite fields, even in the rings, you have various papers. Like if you go to the journals of group algebra, journals of group algebra, the journal of algebra and its application, and you see, you just read the rings and fields over there. You will see lots of papers of a very higher level and very good level. Initially, when we
They
started,
will all be of advanced level, madam. You need to do lot of work, literary work
yeah,
before you can actually probe into those papers. You said the elementary topics, on these also one can do a lot of research. Yeah?
yeah, sir.
So maybe
That is
that is
actually, sir. I want to know the what kind of a level of a research you want to do. Like Gayatri ma'am knows, my one paper last year only got published in Journal of Algebra and its application, and that is a
tell me, madam, your
uh,
papers, you please share your papers so that we can get to know what we have been doing at our levels in
okay,
our
sir.
universities and colleges.
Okay.
Forget about
Actually, the thing is,
international
yeah,
papers
sir.
or something like that. At our own level, we, the faculty members, what we are presently doing,
Okay.
we get to know about it and we can pursue a bit.
Oh, all right, sir.
Can
So
you
you
share,
can
madam?
contact Gayatri ma'am for that. She's working with me right now, so she will be helping you in this way, and she knows what kind of a paper. Recently, we have shared some papers also, so you can. I will ask request her. She can forward it to you, sir.
Please, please, madam. Thank you. Thank you.
Ah.
Yeah, yeah. Any other?
Sir, actually, hello. Sir, actually, I am
Madam,
working.
please tell me, madam.
I am working for under
Madam,
Madam
madam.
Rajni ma'am. I am working. She is my guide for my PhD.
Okay.
Okay, I am working for group actions under her guidance. So anything we shall say, common ideas we can share. We can share, sir.
Oh, why not,
So
madam? Because it's
I'll
a
make.
thing like
I'll
some
create.
papers which have been published by madam or even by your own self. Madam, if you can share the link, we
Definitely,
will
sir.
get to see what currently we at our degree career level we are
I'll
able to
interrupt in
do and
between. So actually, we are
pursue.
working right now, me and Gayatri ma'am. We are working on one advanced version of it, which is a wreath product. It's a product of two groups and with lots of elements. Like we have seen symmetry group. So we are working on the further advanced version of the symmetry group now. And so on that, we are working now. Me and Gayatri ma'am, we are working together. How to find out the conjugacy classes of that? What will be the order of the conjugacy classes? What will be the structure? So that is what we are working. Me and Gayatri ma'am right now. So if you want some basic paper which are related to that, we can forward. She can forward it to you.
Please, madam, one or two papers if you
Oh.
can kindly forward. We'll be
Yes,
grateful
sir.
to
We
you.
will share, sir. Also, at
Yes,
the same
madam.
time, we can think of doing some project work for BSc level and MSc level, sir. We
That's
can
right, madam.
we
That's right.
can
Yes.
grow. We can become, form a group. We
Yes,
faculty
sure,
members
madam. That is
can
what
form
we
a
can
group,
do.
and
Mm.
we can share some ideas about doing projects in
Yes,
algebra.
yes, madam. Yeah.
Yeah, that I will work out for that, sir. Thank you, sir. Thank you.
Yeah,
Yes,
ma'am.
Yeah.
One person, Varsha BJ, she has asked, ma'am, between linear algebra and abstract algebra, which is more advanced and difficult. I will answer this question. It's very dicey for me because I have been a lover of algebra since my teenage. So I will say that both, if it depends upon your level. of understanding that particular subject. That why when I was in my master's in algebra, I scored 98% also, which was your abstract algebra. So I will, because and people used to say over there in my university when I was doing my master's that hardly one people will pass in the university, all will fail, and but I scored 98%. So it depends upon your interest, how much you are into that particular subject. Which one is more advanced and difficult? For me, both are equal. Both are advanced, both are difficult also. It depends upon your interest. If you're more interested into solving the linear equations, if you're more interested to work on the linear equations where the degree of the variables are 1, 1, then it is going to be, you have to work for the linear algebra. If you want to study about the polynomial equations and solving them where the degree of the variables are higher, then you have to go for the abstract algebra. All right, Varsha, BJ, I hope your doubt is clear.
Okay, please.
Yes, anyone? Yes, anyone else?
Any doubt? So, if anybody has any doubt, you can put in the chat box or you can directly ask. Madam is here to clear.
Yeah, please.
Ma'am, here is one question.
Yeah, ma'am, please ask.
That is, I want to know current research going on in algebra.
Ma'am, there's lots of research work which is going on algebra. As I told you, algebra is further divided into group theory, ring theory, field theory, vector space theory. So, in which field you want to know? If you want to know in group theory, right now, as I told you, right now, wreath product is very a hot topic. You can connect, like what right now, present thing is going on is your corona. In corona, how it is spreading, how much calculations fast. You can relate that also with the help of the symmetric groups. So,
Yeah.
but you have to go a little bit deeper into that, how to frame up the conjugacy classes, how many people, how it can get spread and all that. So right now all these things are going on, ma'am. In algebra, it depends further your interest is in which field of the algebra, whether it is in group theory, ring theory, field theory. In every research field, the different researches of a very high levels are already going on.
Madam, can you just relate this algebra to this current scenario, that is COVID, in few words?
Yeah, ma'am.
What?
Because
Few words. Because,
so, but it will be a little bit a higher level because I wanted to tell you a word of permutation group. Everyone must have heard. Then from the permutation group, we have studied about the symmetric group in mathematics. So once we go one step ahead of the symmetric group, that is signed broad diagrams, which we both are doing, or which is also known as the wreath product. Then in that wreath product, if you are able to find out, because what are the elements? If you take n elements in that, total number of element in that wreath product is coming out to be 2 raised to power n into n factorial. So you can correlate if initially the coronavirus is in the n people, to how many peoples it can spread. 2 raised to power n into n factorial, how? That is through the mapping, how it is coming in a contact. So this is how it is correlated, and it will be a very good thing if a new research is going to come on this particular field.
okay, okay. Madam, there is a question which few words about lattice groups. There somebody, as Arvind Nagraj is asking. Can you please elaborate?
Where, ma'am?
Few words about lattice groups.
Yeah, that is also one very particular branch, ma'am. And lattice field, lattice group, and this lattice algebra. Okay, that is also a further specialization. It's a group basically, but you apply a lattice on it, so it becomes a little bit different. So that is how it is going on. So many things are there. And somebody has asked the examples of magmas. Magma is one of the basic algebraic structure. You can take it as a natural number. One of the example of magma is natural number. You consider addition on that, only addition. I'm fixing the binary operation, only addition. The moment you fix natural number with addition, it is magma. Because if you do the subtraction, then it is no longer a basic, even a binary operation on that. Somebody, Dr. Asha CSC has asked this question for me. Okay, so anyone else wanted to know? Ma'am, Gayatri ma'am, one request from you. I think almost 70 participants had participated. If you can take a brief written about the today's this thing. Today's
Yeah, we are doing it. We are doing it. We are
Yeah,
taking the feedback from them.
yeah, yeah,
Yeah.
yeah, ma'am.
So,
Okay. Any
shall
other
we?
queries from respective faculties who are participating over here?
Yeah. We will do that. We will do that. We will take the feedback and all those things.
Okay.
Shall we stop? Shall we?
Yeah, ma'am. It's up to you. If nobody is having any other query, then I'll
Ah.
thank everyone to have a patience to hear me. I'm very thankful to all of you who participated over here, who took a part over this. And in the comment box, I just after completing the PPT only, I can see some good comments also. So I thank everyone for having for hearing me for 1 hour and making this session successful. A special thanks to Mrs. Gayatri, who coordinated this, and her team of the college, AESD, National Degree College. So I thank everyone of this, everyone, and especially the participants, because without the participants, your session cannot be a success. So I thank every participants who spend 1 hour of their crucial time during this COVID scenario to listen to me, to have an ear to me. So thank you everyone. If I have not mentioned anyone, so kindly just ignore that and forgive me. But if I have done any mistake for that also in between the session, I just request you people to forgive for that. And I hope you have enjoyed this session. Thank you so much to all of you.
Thank you, madam. So once again, I wish to thank on behalf of our college, on behalf of our principal and management and our Department of Mathematics. I would like to thank every participant, both faculty and students from different colleges. Thanks for your patience and joining this webinar. Although it is a new technique for us, we have tried this for the first time, and any hitches in this during the webinar, please excuse us. And this is a nice experience for all of us. And on behalf of the department and on behalf of the college, I would like to thank everyone, one and all the participants, and especially Madam Rajni Kanwar for accepting my invitation to give a speech on group theory. Thank you, Madam. Thank you very much.
Yeah, thanks to everyone. Thank you so much.
And special thanks to technical persons from our department, Ravi Kumar, Sangeeta, and Nizam sir, all those people who have helped to conduct this program smoothly. Thank you. Thank you, one and all. Thank you.